Hello, today we will learn about signals and systems. In this module, basically we will learn about the characteristics and properties of signals and systems and also provide some fundamental tools for the analysis and representation. First of all, we will learn about the fundamentals of signals and system, then time domain analysis of continuous time system, then continuous time system analysis using Laplace transform. Remember, this is the system analysis where we use Laplace transform. Continuous time signal analysis using the Fourier transform. And what is the bridge from continuous to discrete? That is the sampling. We will know about the sampling techniques as well. The time domain analysis of discrete time systems and discrete time system analysis using Z transform. So Z transform is for the discrete time system and Laplace transform is for the continuous time system analysis. After that, basically, our learning objectives is that student will be able to know about the fundamental principles of the signals and systems, and they will be able to use some mathematical tools for the analysis of a system response in the time domain especially. And for those mathematical tools we will talk about the differential equations and convolution, and also for the analysis of continuous time and discrete time systems in the frequency domain using the Laplace transform, Z transform, respectively. And how to apply the Fourier transform to analyze signals and sampling theorem to bridge from continuous to discrete, and represent and manipulate signals numerically to solve engineering problems. So this is a book that is good for it. So this is just about the introduction of the what we are going to study. Now, as a background, first of all, you should know about the complex number. So complex number is basically an extension of ordinary number. Remember this thing, and are an integral part of the modern number system. And if we want to denote, let's suppose z, we want to denote this complex number by z equal to a plus jb. So here this is known as the Cartesian form of a complex number z. This is Cartesian form, okay, or also known as rectangular form. It has two parts basically, a and b. A is basically the real part and B is the imaginary part. So we can show the complex number on the plane. All real numbers that will lie on the horizontal axis and all imaginary numbers lie on the vertical axis, like this you can see here. Complex number can also be represented in the form of polar coordinate, in terms of polar coordinates. So, like, let's suppose if r and theta are the polar coordinates of a point z equal to a plus b jb. That is the Cartesian form. Now, it is what the Cartesian form. So, we can express this in terms of polar coordinates. How? A equal to r cos theta and b equal to r sin theta. Now we see here that if we further write in this form, so r we can take common from both terms like this, and inside cos theta plus j sin theta. This is the equivalent formula that states that this thing, that if we have e raised to the power j theta, so that is equal to cos theta plus j sin theta. And if you observe further, we can represent the polar form of a complex number z. How? With the help of e raised to the power j theta. And r is the real part, as you know, and e raised to the power j theta, that is here. This representation is the polar form of complex number z. Summarizing a complex number can be expressed in rectangular form like this, and a polar form r e raised to the power I theta. And where This is very necessary, that how to calculate the r, that is a square plus b square under root. And you know, a equal to r cos theta, b equal to r sin theta, and theta can be obtained by tangent of b over a. So these are the some equalities that will help us, but don't go in a lot of depth. And if let's suppose there is an example where you have a complex function of a real variable omega, the function is given to you. This is x of omega, is basically a function that is given to you, and what you need to do, you have to represent this in the form of Cartesian form and find its real and imaginary parts. So how you can do that? Simply some mathematics involved over here. Like, first of all, you need to eliminate the imaginary term in the denominator. So how? With the inverse, like here plus, you just have to minus and you will multiply and divide the both term. And then simply you are going to multiply this 2 with 3 and then this 2 with minus j4w. And similarly, after that you will multiply jw by 3 and then by this. After solving, you will get the denominator like this, and numerator like this. And in the denominator, the formula that is applied, like you know, if a plus b, a minus b, so in mathematics it is equal to a square minus b square. So the same thing if you do over here, so you will get here plus, here minus. Okay, and 4 4 are 16, w is going to be squared, 3 3 is a 9. Now as here it is minus, okay, so it is going to move here plus as well, and it is then mathematically solved in this form. This is the Cartesian form of x of w. Clearly, the real and the imaginary parts you can see over here. Like this is the imaginary part, and here, like you can see, you are able to find the imaginary part as well and real part. Like this is a, okay, this is imaginary part, and you know, this is b, that is the real part. So there are some more examples, but not all are very important for you right now. So we can just go through them. You can study it yourself, but not very important. Okay. After that, we will continue in the next video. That is more important. It was just for some background refresh knowledge. It will be available. These all notes are available in the description box as well, and you can download them for your further studies. Thank you.